Welcome back for lab 2.3, burning steel wool. So this lab is all about percent yield. And we're gonna see, sorry guys, I've got a helper today. It's my son, Levi. So our lab today is all about percent yield. So we are gonna look at what we actually collect and compare that to what stoichiometry says we should have gotten in a perfect world. So we're actually grading ourselves on this reaction. This is the exact same process you use to calculate a test grade. You look at how many points you actually earned versus how many points were possible. A perfect score, right, times 100 gives you your percentage, right? So chemists can grade themselves on their reaction because we know in a perfect world what we should have gotten. So let's look at our last lab. So our last lab, we looked at copper chloride reacting with aluminum. So we did some reactions, and stoichiometry told us that if we used up all of our copper chloride, we should have gotten out exactly 0.25 grams of copper. However, I only collected 0.10 grams of copper. Was my reaction really good? So if I wanted to calculate my yield for this reaction, I would look at my actual, what I in the real world physically collected, and I would compare that to what stoichiometry told me I should have gotten. So this number right here, and the hardest part about these problems is figuring out what's the actual and what's the theoretical. Sometimes you see the words flipped, and it will be the experimental versus the theoretical, or the experimental versus the actual. So in that instance, the experimental will be what you actually collected. But I like to use the term actual as in what I actually got, and theoretical as in what in a perfect world we should have gotten. So this one would be my actual. This is what I actually pulled out of my beaker. This would be my theoretical. This one is in the perfect world. So let's compare them. So 0.10 divided by 0.25 times 100 equals my percent yield. So I'll give you a second to do that math, and we'll come back. Guys. Looking at my reaction, 0.1 divided by 0.25 times 100 gives me 40%. So I had a 40% yield on this reaction. It's overall not very good. There's a lot of sources of error for this reaction, right? We saw, if you watched the video, there was a lot of copper I left on my aluminum foil. I didn't rinse it out very well. So typically chemists like to have a 90% yield or more, right? Obviously, the closer you get to 100, the better the chemist you are, and the better you were at minimizing your error. Getting a perfect 100% yield is almost impossible. Because there are lots of sources of error in the real world practically. So if you ever take analytical chemistry in college, that's where you'll learn about all those ways to minimize error. But for us, that's beyond the scope of our course. So I would expect a good theoretical yield, or a good percent yield for you guys would be above 75%. So anyway, this reaction is a chance for you to get a real feel for how to calculate a percent yield. This reaction is fun because it gives us, we're going to see in a minute, a very wow factor reaction. So we are going to be reacting steel wool with a battery. And we are going to be producing something that I'm going to let you guys kind of figure out. So this is not a combustion reaction, even though we are burning things. And this is not a combustion reaction because we're going to produce something that's different. Technically, this reaction would be a synthesis reaction. So let's look at what we have. So this is our steel wool. Yours, I think I just gave you a good wad already in your lab kit, right? But here's what it looks like. just like a steel Brillo pad, right? And I'm going to fluff it out here in a minute. And we're going to be reacting that with a 9-volt battery. Now, it's very important that you keep these things separate from each other. This reaction is, once it gets going, it's almost impossible to stop, and it is going to spark up. So you don't want to start the reaction until it's safe for you to do so. So we're going to need to let our fire happen inside our aluminum foil boat. Your instructions ask you to weigh this before. Okay, so I've got my steel wool, and I have kind of broken it apart. Surface area is important for this reaction to happen. So you see I've kind of fluffed it out. Right, you can see it's kind of shiny. So for this reaction, we are going to be putting our battery up to it and seeing what happens. And we are gonna see this stuff start to burn. So when things burn, they are reacting with oxygen in the air, right? If this reaction were to happen in a vacuum, it wouldn't happen at all because some oxygen is gonna be used for this reaction to happen. This is not a combustion reaction. We're not reacting it with any carbon, so we can't produce carbon dioxide and water vapor. So it's not, don't think about this as combustion. So looking at this iron reacting with our oxygen, I want you for a minute to think about the types of reactions we've studied about and try to predict what you think is going to happen, right? And how you could maybe predict that product. Okay, so let's do the reaction. And like I said, this reaction is going to happen very quickly. It's once it's going to go until there's no more iron left there for it to react. So like I said, another safety plug, don't put our battery or any flammable open source of flame next to the steel wool because it's going to burn very, very quickly. You want the reaction to happen to all of the steel wool. So we might need to touch it, touch our battery to it in a couple of different places, especially if you have a big wad of steel wool. So I'm going to show you. So I've got my battery. I've got the leads on the battery, the positive and negative ends. I'm just going to bring it close to my steel wool, and you'll see it start to react. So the more oxygen we have that can kind of get in there for this reaction to happen, the quicker it's going to happen. And you'll see those little fires going through the whole thing of steel wool. If you have a big wad of steel wool, it's okay if you touch the battery to it in a couple of different places. Just know that this stuff kind of likes to spark away. So if you have it going pretty violently, some of your product is going to fly away and get caught, especially if you have a fan on above it. And you'll see that it turned a different color. Right? So we're going to let this reaction go, and then we're going to examine it. We want to make sure that all the steel wool that we have weighed. Remember, you're going to need to weigh your steel wool before this happens. You're going to need to react all of it, right? So if I'm looking at it, you can clearly tell what's reacted and what's happened because there has been a color change. You can also try, if you need to, touch the battery to it. See, there's a little bit of unreacted. If I flip it over, I can see this is unreacted, so I'm going to hit it back there and let all that go. And there's also a spot over here. I don't know if I can get that to go. I didn't want to react. It is really rainy today, so humidity sometimes makes this not work. So I'm just gonna kind of be patient with it and play around with it until I get it all reacted. And you can too, kind of have fun with it. This is a really fun reaction to watch. Oh, there it went a little bit. I might have some special coating on it. Oh, there we go. There we go, I got it. It's gonna let it go. Got my battery positioned wrong. Okay, anyway, so that's going. Now there's not really much to this once we do the fun of having our, get as much as we can of our aluminum to react, or our steel wool to react. Sorry, this is not aluminum. Our steel wool to react. You can do this reaction. You can try it a couple of different times if you got enough steel wool, or if you want to just, buy some more, you can get it at the Dollar General. Right, anyway. So, looking at our reaction here, what do we think will happen to this mass of our aluminum once we burn it? I want you to kind of think about that, and then I want you to finish this reaction, and then I want you to weigh your product, right? And see if the reactions might surprise you. So, this reaction, you will require, as you walk through the procedure, it's going to ask you to predict these products, and it's going to tell you that assume that the iron that you used had a +3 charge. So iron is one of those transition metals that can have multiple charges, but its most common one is +3. So think about that when you're predicting your product over here. And I'm going to give you a hint. This reaction is a synthesis reaction. Right, so that tells us we're just going to produce one thing. If we've got both of these, you should pretty quickly be able to figure out what the product of this reaction is going to be. You're also going to need to balance that chemical equation in order to get your stoichiometric coefficients, because we're going to need to compare our actual yield, so the weight of our actual product here. Assuming we burnt this to completion, right, the weight of all that's left on that aluminum foil should be product, our one product. And then you should be able to compare that to what stoichiometry from our balanced chemical equation tells us. So